At the peak of this crisis, around 720 Airbus A320neo family jets were sitting on the ground, not parked overnight between flights, parked for months, engines waiting. Most of these aircraft were nearly new. And here is the part that stops people cold. Not one of those engines had failed. Nothing broke in the air. Nothing caught fire. The airlines pulled these jets out of service on purpose because of a flaw you would need a microscope to see. To understand why, you have to look inside the hottest part of the engine. The engine is Pratt and Whitney's PW1100G. It is a geared turbofan, or GTF, and it was supposed to be the efficiency breakthrough of the decade. A gearbox lets the big fan and the core spin at their own best speeds, and Pratt & Whitney marketed it as around a 15% fuel burn improvement over the engines it replaced. The engineering worked. The problem was not the design. The problem was hiding in the raw material of a few small, spinning discs deep inside the engine, the high-pressure turbine and compressor discs that hold the whole hot section together. Those discs are made with powder metallurgy. Instead of pouring molten metal into a mold, engineers start with a fine metal powder, then press and heat it under enormous pressure until the grains fuse into a single solid part. Done right, it produces a very uniform, strong disc that can survive tens of thousands of cycles at brutal temperatures. But it depends on the powder being clean. A single microscopic particle of contamination trapped inside during manufacturing becomes a flaw baked into the finished part, a tiny weak spot in a disc that spins at thousands of RPM. In 2023, Pratt & Whitney disclosed exactly that. A batch of powder used to make these discs may have carried microscopic contamination. In a spinning turbine disc, that kind of hidden inclusion is where a fatigue crack can start, and a turbine disc is not a part that fails gracefully. If one lets go at full speed, fragments can punch straight through the engine casing, so the question was no longer whether the engines were flying fine today. They were. The question was how many of them were carrying a flaw that no routine inspection had been built to catch. Here is why the industry treats this with zero tolerance. A turbine or compressor disc is what mechanics call a life-limited part. It carries a hard cycle limit, a fixed number of takeoffs and landings, after which it must be scrapped and replaced, no matter how healthy it still looks. The reason is low cycle fatigue. Every flight heats the disc, spins it up to full speed, and cools it back down, and each of those cycles does a tiny bit of invisible damage deep in the metal. A hidden inclusion accelerates that clock. It gives a fatigue crack a place to start long before the disc reaches the life it was certified for. So a flaw no eye can see can quietly retire a part that was built to run for decades. Because you cannot see the flaw from outside, and you cannot predict which discs came from the bad powder, Pratt & Whitney could not simply inspect on the wing. The affected discs have to come out of the engine, which means the engine has to come off the aircraft and be taken almost completely apart. Somewhere between 600 and 700 engines are being called in for this teardown through 2026. That makes it one of the largest precautionary engine inspection campaigns the industry has ever run. And that is where a manufacturing problem turned into a logistics problem. Here is the math that broke the system. A normal overhaul for one of these engines used to run 60 to 90 days. A powder metal shop visit now runs 250 to 300, and that is once the engine gets a slot. Pratt & Whitney's overhaul network was built for a steady trickle of engines coming in for scheduled work. It was never sized for a whole fleet showing up at once, so much of the fleet is stuck waiting in line for a bench that is already booked solid. The delay is not just the teardown, it is the traffic jam in front of it. When you cannot get an engine back for the better part of a year, airlines get desperate for hardware. So the industry did something almost unthinkable. It started cannibalizing brand new aircraft. Nearly new A321neos, jets that had barely earned their paint, were pulled aside so their engines and components could be stripped out and hung on other aircraft to keep those flying. The scale of it is something even veteran dismantlers say they have never seen. The head of one aircraft recycling firm said they cannot remember it happening on this scale before. That is the real cost here. The parts shortage is so severe that a factory fresh jet is worth more disassembled than whole. It is finally starting to ease. Pratt & Whitney reports groundings down about 15% from the peak, and overhaul output up around 23% year-over-year as new shop capacity and inspection lines come online. Meanwhile, a redesigned version of the engine, the GTF Advantage, was certified by the FAA and EASA in 2025 and is entering service in 2026, built to be more durable from the start. The powder problem is being ground down, slowly, one 300-day shop visit at a time. The lesson of this whole episode is not that Pratt & Whitney built a bad engine. It is how little margin the modern aviation system keeps. One contaminated batch of metal powder, invisible to the eye, was enough to park a fleet, cannibalize new aircraft, and clog engine shops for years. The machines can be fixed. The deeper vulnerability lives in a repair network that was built with no slack to absorb a surprise this big, and a network is far harder to redesign than a disk.